Thank you. We give you praise. Lord, we exalt your holy name. Since this program began, we say thank you. We adore you. Be thou exalted in Jesus' name. Father, we commit today's program into your able hands, O Lord. Have your way in Jesus' name. Take charge. At the end of today's program, let's have full call to glorify your holy name. For in Jesus' excellent name we pray.
Thank you. Thank you very much. So, without much ado, let's just call on our facilitator to take us on. Thank you.
Okay, thank you very much, ma'am. Okay, good morning, everyone. How was your night? Hope it was good. It was built into containers, right? Okay, thank God for that. Nice one. Okay, we'll just quickly do a recap of yesterday, then we'll continue. So yesterday I started with containers and I showed an analogy of a house container of how it has everything built into it, the bedroom, everything, and the kitchen, the bathroom, everything that is needed to have a basic life is in this container. So we relate this to a house, to a software container where an application and all its dependencies are packaged into the container. So an application, its operating environment and all the dependencies the application needs is packaged into container. Containers are mostly stacked, layers of stacked images. So we have our base image and all other dependencies are built on this base image. So no matter where you run a container, it will yield the same results. So we have the importance of containers, and I think we discussed this. So let's just skip. So with comparison between containers and virtual machines, we can skip this. So what is Docker? This is what we use to build containers. Simple as that. This is the technology that is used to build containers. It provides the ability to package and run an application in a loosely isolated environment. It makes deployment of application very fast, easy, and it aids continuous integration and continuous deployment. So we talked about the architecture, about the client, the daemon, the server, and the registry. So we all got to see the registry yesterday, and we all got to experience with the client and the server yesterday. So images are templates with instruction for creating container. Images of why containers are runnable instance of that image. So we looked at some of the commands yesterday. So I've added the color coding so that people can see that. Okay, so these are all the. So I guess if you guys really did what I asked you to do, you will have practiced these commands yesterday. Yeah, just to see how it works. That's the way you will learn is by practice. So these are the different commands you can run. So important one, Docker PS is list all running containers. Docker PS -A list all running and stopped containers. So to start a container, you use Docker run or Docker start. To stop a container, use Docker stop. To kill a container, use Docker kill, and so on and so forth. So the practical I gave you, you can use it to learn also. So yeah, we've learned about containers, about Docker, which helps us to run containers. So, but how do we build images that we can build we can run our containers from? So Docker images are templates that contain a set of instructions for creating a container that runs on the Docker platform. It is a convenient way to package up applications and pre-configured server environments, which you can use for your own or you can share publicly with others. So important, I've been hammering on this. You have an application and you want to package it in a container. So you package the application with the operating environment and the dependencies needed for the application. So everything all containerized into a container. So I use this analogy to talk about how you build your own containers. So let's say you want to install Google Chrome on a system that has no operating system. On a laptop that has no operating system, what do you do? First thing is you find an operating system, either Windows, Mac, or Linux. That's the first thing. So that's the base image. You are laying the foundation. So that's the base image. So in every image, you have to have a base image too. So the operating system, then all the other steps you need to install the Google Chrome browser, like start up your default browser, navigate to Google Chrome in your browser, download the installer, open the file explorer and execute chrome.exe, chrome installer.exe. So these are the commands that you need to run Google Chrome. So these commands like build up on the base image by installing the dependencies to use to achieve your goal or arrive at your goal, which is installing chrome.exe in your system. So the last one, so we see that these all are grouped into the commands that you use to install additional commands, additional programs, and install your dependencies. So the last one is command to use to start up, to run at startup. So these three different things are important. There are three different phases that you use when building an image. Sorry. Specify base image, run commands to install the dependencies of that base image, and start up your application. So for a Docker image, I want to create a Docker image to run an application. I specify the base image first thing. I run commands, different commands to build, to install the dependencies of that application. And I specify a start command that will run the container. Every container you run has a start command. It has a start command. So that's the entry point of the Docker container. So I show an example of a Node.js server here. So this is the base image. So because I'm running a Node server, I'm using a Node base image. If I was running a Python server, like a Flask server or Django server, I'll be using a Python base image. If I was just running some maybe bioinformatics tool as we use in my cluster, I'll be using some Ubuntu base image. I think I have some example. Let me even show it now. I have some example Docker images that I can show. Thank you. That I can show you people. I open them on my browser. Okay. Okay. So we can see here, this is an example Docker file. Very simple for a Python application. I hope it's clear from the back. So in this case, we are running a Flask app. We are running a Flask app. So the base image is Python. So we are using Python. Who can tell me what this 3.8/slimbuster is? The tag, yeah. That's the tag. So that's the version of the Python that we are using. So who can tell me what this work_dir/app is? Yeah, the working directory, active directory. So we are saying create this working directory for me and make it the working directory which other subsequent commands will be run on top. So who can tell me what this copy is? Copy requirement.txt to requirement.txt. Who can tell me what it is, what it does? Okay, yeah, something close. It's close. But what does the copy do? I think, yeah, exactly. So it will copy this requirement, but where does it copy this requirement from? This first requirement.txt. Where does it copy it from? From the content. No. Let me just say it. So when you are reading your Docker file, your Docker image, you specify a context. That context is your local directory on your system. So you are copying, so Docker needs that context to know where to copy files from. So you are copying this requirement.txt from your local file. The context is specified from your local system, not local file, from your local system. That means your laptop, into the container. So into this directory, this working directory you have specified. So this requirement.txt will go into this /app directory. So copy requirement.txt from my context, which is a directory on my local system, into requirement.txt into this /app and name it requirement.txt. So that's it. So it's just copy from your context, from your local a context, which is a directory on your local system, into the directory, your working directory in your container. So the next one is run pip3 install. So this is just installing the dependencies. And I mentioned yesterday, this pip3 is available because we are using a Python base image. If I was using a Node base image, this pip3 will not be available. So this pip3 is used for installing Python dependencies. So this run is used to run any command. It's used to run any command. You can run any Linux command that you want. Then copy dot dot. Copy dot means copy all the files in my current working directory on my local system as specified by the context into the working directory of the container. So that's what it means. Then this, every Docker file has a start command. So when I start this container, so this Python 3/m flags, all this will run. All this will run. So this is what the container will use to start. So three things: your base image, your set of commands to install dependencies, and your start command. So, yes, sir. From your local system, when you are building your Docker file, you specify a context. That means a directory on your local system. And you copy it into the working directory of the container. So that's an example Docker file for a Python application. So let me show you some more complex one. This I don't follow contemporary Docker formats, but it's still a Docker file. So for bioinformatics that I work in, so there are some Docker files, so it might be a bit complex, but we can walk through it. So this is an example Docker file. Okay, so this is another Docker file for creating an image. So this one uses a different type of base image. But who can tell me the base image from just the name? Who can tell me what the base image is? Okay, let me just say it's Ubuntu. So it's an Ubuntu base image, but it is gotten from another repository. There are different repositories. The common one or the official one is Docker Hub, hub.docker.com. But you can use other repositories or other registries. So this is from Kwe.io. And this is the probably the ID of the person that owns the image and Ubuntu 20. So this is just to name the owner of the file, maintainer. You can do that. So run command is used to run a series of commands on your container, like build, install dependencies. So we can see is doing some updates first on the Ubuntu. Is installing RBase core on the motor. It's using the /-y so that it can skip all these terminal prompts. Then it's installing, it's doing another install. It's installing build essentials. It's installing wget. It's installing zlib. It's installing liblas and laplace and fortran and so on. So the run command is used for installing dependencies or running Linux commands. So that's very important to know. So it's running other commands. So this container, it doesn't have a start command, but it will use the default start command of the base image. To use the default start command, which is just start a bash shell, I think, for Ubuntu. So this is another simple base Docker file. So let's go on with the slides so that we can do our practical. So this is a Docker file for a Node application. That's why we're using a Node base image, because we want to run a Node application. So whatever application you want to build, you use the base image for it. So env just specify an environment variable, working directory, copying this package.json from my context into the working directory of my container, running npm install. This npm is available because we are using Node. Expose 4000 means expose the port. Copy dot means copy all the files in my current working directory into the working directory of the container. Another run command to build the application. This just builds the application so that it can be saved by the server. And this is the start command for the container. npm start. This will start the web server so that it can receive request. So we'll go through all this in the practical. So I've talked about the from command. It's used to specify the base image. The run command is used to run commands on your application, on your base image, or run Linux commands. The work dir, which is used to specify the working directory. The expose, which is used to expose a port. But note one thing, when you are exposing a port, you still have to expose it when running the docker run command. When running the docker run command. So it's important. So if you expose a port, in the docker run command, you have to specify the port you are exposing and the port on the local host you want it to be exposed to. The copy command, we've talked about that. Then the cmd, which is used to specify the start command. So this is the same Docker file. This is another Docker file. I think I explained this yesterday. So we can see an example Docker. So this is like built into phases. This is the phase, first phase, the builder phase. Everything is what I explained. Then this is another phase, which uses the ngins command. So the expose command, we know what it does. It exposes a port. The copy command copies a file from our context, or in this case, it's copying it from the working directory of the container into another folder in the container. Yeah. For the nginx server. So this is copying it from the phase one, from the builder phase into the another directory in the container. Yeah, you can do it as much as you want. Yeah, you can do copy run as much as you want. Let me even, you can do from very limited. Maybe if you want to specify several phases, maybe 2 or 3 times, not as much. You can specify several phases. You can do run as much as you want. As much as you want. You can do work there once. Though you can, maybe after you specify a working directory, you do some run commands, some copy commands, you specify another working directory. But you don't just do it as much as you want. You can do expose as much as you want. You can do copy as much as you want. You can do cmd as much as you want. It's just one. If you specify more than one, it's the last one that will be picked up. So you can't do it as much as you want. So let's move fast so that we can do the practical. So now that you have a Docker file, how do you build it into an image? Because it's an image you convert to a container. You just use the Docker file to give the Docker daemon instructions to build the image for you. So to build the image, you specify Docker build, the name of the Docker file, and the context I've been talking about. So this is the more full version. Docker build, the Docker file, a tag name, and you specify the name of the image and the context. So with this command, this will tell Docker to build the image for you and give it the name that you specify. If you don't give it a tag name, to give you a default name, that's the way Docker was. It give you a default name. I might not like the name, or you might forget the name. Then you specify, very important, you have to specify the context, which is the directory on your local system where it will copy files from. If you don't specify it, it will fail. I can even make the error. So if you want to push to your repository, because you can have a repository on Docker Hub, like we saw in that former base image, koe.io/c something/ubuntu. That's actually someone's repository ID. So if you want to do that, You give it a tag name. First, your Docker ID or your repository name, then your app, then the tag, then the context. Very important. So to create your repository ID, you can create it now, or I expected you should have created it. So you go to dockerhub.docker.com. I think some of you created the account yesterday. Yeah, so you have a repository ID. You had to do it. Okay, that's good. So I spoke about volumes. I said something about containers. They don't persist data. If you run the container and you create some files on it, and you delete the container, all the things you create on it is gone. Forever gone, no can be gone. Even though you restart the container, forget it, it's gone. So to keep data on containers, in containers, Docker provided Docker volumes as the way to keep it. So it helps you map a folder on your local system into a folder in the container. So that's what this image is showing. This is a folder on your local system and it's mapping it into a folder in the container. So everything in that folder, not even all the folders in the container, everything in that folder is only what is backed up, is only what is persisted. So it will help you to save data on your folder. Pay attention, I'll ask the same questions I asked yesterday. So there are two ways of creating volumes. There's the named volume. There are three ways actually. There's one anonymous volume, but they are not so useful. But named volumes is the first one. You specify the name of the volume, then the part in the container you want to back up or you want it to persist. The name, any name you want. You can specify. You can see the example here. I'm just using feedback. So -v. So this is done when you are running the container. You see Docker run. When you want to run a container, that means create the container, use Docker run. And it's specified when you are using Docker run, you use -v, the name of the container and the part in the container you want to back up. So there's a question coming on this. Let me just quickly give you a tip. So if you want to list the volumes that you have on your system, then you use Docker volume ls. So name volume is the first one. You just specify the name and the part in the container you want to back up. There's the other one, bind mounts. Bind mounts, in these named volumes, the Docker system will create it anywhere in your local system. You won't even know where it created it. It's created anywhere in your local system that is hard for you to find, and all the files are backed up. But I think Windows has upgraded their OS that you can now find it sometimes. But if you want a case where you know where the files are stored, or you want to map a particular directory that some files are into your container, so the files that are available in your directory are also available. There's other files that are available in your container. Your container is isolated. It's isolated from your system. If you want files that are present in your local system into a container, you use bind mounts. So it's useful when you want during development of a code base to synchronize the files and folders of your host computer into the files of your container. Yeah. So to create it, to specify it, you also do it when you are using the run command, when you are creating or starting the container. So you use the -v also and specify the full path to the folder. Important, the full path from your root directory. So for Windows users, it will be from your C drive. And for Mac users, I don't know, from your app folder. I don't know the root directory. Then the folder in your container that you want to back up, there should be a slash. So this is the full one. So here I'm specifying the full path from my root directory. And I'm using the colon here and the path I want to back up in my container. So we'll be doing some examples in Docker Compose. So Docker networks, if you want your containers to talk to each other, because they are isolated environments, they are not supposed to communicate with each other. If you want them to communicate with each other, you use Docker networks. And Docker does this thing, like it gives every container an IP and a host name, and it resolves the host name into the IP for you, all done automatically. You don't need to disturb yourself. So if I want to connect to this container one, I just need to pass this container one to the place that the network we use to talk to it with the ports. That's all I need to do. Container one is the host name. So this is what you can use to communicate with each other, the host name, and Docker will do the DNS resolution for you. I guess we all know what DNS is. So this is the practical. We want to Dockerize these multiple services. So it's a web server, it's a full stack application, a Node.js backend and a React frontend, and uses a Postgres database and an Nginx web server to route traffic either to the backend or the frontend. So we'll start first by building the database, then we'll build the backend API, then we'll build the frontend API, then we'll build the Nginx web server, then we'll be able to visit it from our browser. So that's the first practical. So later we'll do Docker Compose. Do you understand? Okay. So we've been speaking about containers, about containerizing applications. So now we want to put this into practice. So this thing we are seeing is a full stack application, as a database, as a backend server to serve requests, to give resources out, data, to serve data, and the front end, which is your UI, your user interface, so you can type things in it. So we'll be building containers for this, and we'll also have an Nginx server, which we can send requests to send requests to either our backend or our front end. And our backend will talk to our database. So we're using some kind of network here. So this communication that you're seeing is some kind of network communication, number one. So your database, is a container, and containers naturally don't back up data. So we're using a volume to do the backup data. So we'll be practicing everything we've learned up to now. We'll be building the images. Though I've already done the Docker files, so we'll just go through the Docker file and see. Then we'll build the images ourselves. We'll run the containers ourselves, and we'll try out the application ourselves. So this is a web application. Okay. Any other question? Do you understand? It's okay. We can go on. My guys at the right side. Is he okay? It's okay. I'll ask questions. So. Okay. So it's a simple application. So we'll be able to visit it from our browser. But we all know what Nginx is, right? Do we know what Nginx is? Okay, it's a web server. It's an application that is used to receive requests and send out a response. When you go to your browser, you type your URL and you press enter. What your browser is doing is sending a request to a server. So that server will have something like Nginx. There are several of them, Apache, Nginx, that will receive that request and know what to do with that request and send a response back to you. So most times it sends HTML back to you, to the browser, which your browser will now render for you to see. So that's what Nginx does. It's a web server for serving applications. So in this case, the application we are serving is our backend application, and in this case, it's a Node.js application. And our front end, which is a JavaScript application, a React application. React is a front end framework for building web application. So this web application, this front end application is just what you see on your browser. It's just the UI you see on your browser. Okay. Yeah, front end. That's why it's front. So it's what you see, is your user interface that you see on your browser. So when you are making an application, you want to persist the data, you want to save the data. So if you create a user, let's say you create an application now, or like everybody that came to this conference, you want to know who came. You need a database. In this case, maybe it's barrier and paper we use. You need somewhere to save the data. So in this case, we are using a Postgres database to save the data that we want to use for this application. So that's all it is. It's a web application. So if you have any questions, you can ask no matter how crazy it is, so that I can use it to explain. Because I've tried to explain as well. Okay.
The arrows in this diagram, I've seen that only one is dual directional. there is a communication between NGINX and the front end, which is a dual-way communication, but others are single. Is there any reason for that? Because I was expecting that there should be double flow. I don't really understand what I mean. Okay.
Yeah. Why did I do it like this? I hope the black stuff is not covering the error. It should actually be directional. Double, is it unidirectional? Bidirectional. So the database will send a request to the Postgres database. The backend will send a request to the Postgres database, and the Postgres database is supposed to reply with the information that it wants, and we send it back. Actually, in this case, okay, yes, send it back to the NGINX. We send it to the front end. You get? So the request comes from the browser, which is the users. It goes to the NGINX. It looks, okay, where is this request going to? Is it requesting for a backend resource or a front-end resource? So you notice, okay, it's requesting for a front-end resource. It goes to the front end, and the front end responds back, and it goes back to the browser. That's where it is. That's where it is. So it could be a backend resource. Even the front end can request for a resource. So I guess that's why I put the double arrow here. The front end, if it goes to the backend, and they notice that, okay, it needs an information from the backend. If it goes to the front end, it needs an information from the backend. The request goes to the NGINX, and the NGINX sends the request to the backend, and it fetches the data from the database and sends it back to the front end, which sends it back to the browser. So the arrows, I think maybe is covered by the boxes. Yeah. So let me say it again. No connection. No direct connection. No. So it's only the backend that talks to the database. You don't want your users to be talking directly to your database before they go and collect information that they're not supposed to collect. If it's a banking application now, someone will just scroll to someone's bank account and carry out the money, jackpot, next thing. Okay. So, as I've said, the browser is us, our systems. We open the browser and we send a request. The first thing it gets to is the NGINX server, which is a web server. So this looks at what the request and looks at what the person wants. Most times it's the front-end application. So it goes to the front-end application and says, okay, please give me your HTML file, your index.html. So in the index.html, there might be some requests for information in the backend. The front-end server sends a request to the NGINX that, okay, I need this information, and this goes to the backend. So the backend goes to the database, fetches the information, and sends it back to the front end. The front end renders it, sends it back to the NGINX, which sends it back to the browser. Okay.
Yeah, good morning. This NGINX, you said it's a server, right? Web server. It handles requests. It receive and send back. So I just want to know on which protocol does it work? Which protocols does it use? Protocol, yes. Internet protocol does it works, yeah.
So I know NGINX uses HTTP protocol or HTTPS protocol. It might also use other protocols, but what mostly developers use it for is the HTTP, which is the Hypertext Transfer Protocol, or the HTTPS, which is the secure version of the HTTP protocol. So that's mostly the protocols browser used to communicate with web servers. So it uses the HTTP or the HTTPS protocols. Is mem. Okay, okay. You know, when you just the HTTP is just the protocol for sending information. The request has some data with it, either JSON or image data. I think is in buffer. Sometimes it buffers it in binary format. So that request has some additional. This is just the protocol for communicating. You know, there's the OSI model that goes from HTTP to TCP to several other models. So this goes on between the server and the client. So your request has some additional data. So those additional data, it might be JSON, it might be your image, it might be your audio, but the mode which they use to communicate is still HTTP. So you might have additional data, which is where your MIME command comes from. So when you are communicating, you specify a format in which you are using to communicate. HTTP is the protocol. You specify a format. It can be application. Yeah. No, it's the browser that will specify it for you. You don't need to specify it yourself. So it might be application.h/html, which is the default format. It might be application/JSON. It might be application/file. I think text file also. Or I think it uses MIME format for text, for audio and text files. It might be application/that, and to communicate with that. So the protocol is HTTP. They always come, the request has some data with it. So those data are what, like, or your audio, your text, your data, and everything. Yeah. Okay, it's almost 9:50. Let's quickly go through the practical. So we all have these files that we want to use right now. Let me go to the Docker, um, to the GitHub repository. Yeah, the first file we downloaded yesterday. So go to the multi-container folder. Multi-container. So um I d- I don't know if you have a text editor like VS Code or WebStorm or Sublime Text. No, no, no. I want you to open the folder. If you can open the folder, it will be good. In VS Code. Yes. Front end. Yeah, yeah, that's the where the code is for. No, no, I want you to open the folder itself. If you can open the folder, no problem. No problem. Or you can just look at my screen, but it would have been good if you can open the folder. If you have VS Code. If you don't have VS Code, no problem. You can just follow along with me. If you don't have a text editor, don't worry. You can just follow along with me. But everybody must run this code on your system. Everybody must run this code on your system. Please try to run so that you can see, you can practice it, and you can understand it. You can run the Docker run. So the code you want to run is in the multi-container underscore content It's on the practicals underscore multi-container.txt. Yes. No, a text editor. You can use Notepad. Anyone. And but you won't open the folder. You will just open the file I asked you to open. The reason I'm saying use VS Code is because you can easily navigate the folder and open the specific thing I want. But you can also open it in Notepad or Notepad or any text editor you have. I'll just see the file that we should open. I think that's fine. No, no, no. Use your terminal we used to run the command. So it's terminal. This is just for ease of use. It's just for ease of use. You can also follow along with me, no problem. We open plenty terminal, like 4 or 5. But let's start one by one. So, okay, let's look at the practical. Let me see if I can increase the size. Okay, so the first thing we'll do in this practical is to create a network. And remember, network is just to allow containers to talk to themselves. We want our backend to be able to talk to our database, and we want our NGINX server to be able to talk to our front end, and we want our NGINX server to be able to talk to our backend. So we need a network to allow this to happen. So Docker provides opportunity for us to use Docker network to allow our containers talk to each other. So the first thing we will do is to create a Docker network. So please open your terminal. Open your terminal. Open your terminal. I guess everyone has Docker running now. Extract it, then open the multi-container folder in your VS Code. You can just right click on the folder and just open with code. No, no, after you extract. Okay, you can also use terminal in VS Code.
there's no need for this.
Anyone you want. Multi-container. Yeah, just right click and open it. No. You have VS Code, right? So right click. Open with code. No. Are you using Windows? 11. Okay, maybe it's different from 11. Okay, then open VS Code. Just open VS Code. So then navigate to that direction. Open file. Or open folder. Open folder. So navigate to that direction. You have virus in it. It should show your folder. It should show your folder. Okay, no, this is in the zip file. You have to extract it first. You have to extract it first. Yes. Okay. Yeah, yeah. Okay, no, but you didn't open the folder. Where is the file? Which one is open with screen? No, no, don't open it. It's the folder I want you to open.
I open it from this file open. That's what I did.
This is open. So you have everything. So if I say go to a file, you can just okay. You can just come here.
Okay.
So now, yeah, good. So you can use the terminal in your VS Code too, or use a normal terminal, anyone you want. Okay. Yeah, very soon. Can you see my terminal? Okay. I prefer PowerShell, sorry. It allows you to use some Linux commands sometimes. No, for Mac users, just use your terminal, no problem. No, you have it now. Okay, no, you don't open it. Where is the folder? Oh, so just open PowerShell. You can just click here. So it's open and close it. Okay, so let's start. So the first thing we want to do is to create a network. Please, let's pay attention. Please, let's pay attention now. My questions are coming. I will ask questions now. Sorry, I hope I've not forgotten people online. People online, hope you are following, Sha. Are you there? Okay. Yeah. No, you don't have terminal in some Sublime Text. So let's move on so that we can finish. So let's create the network. So create network. Okay, so for me, it already exists. So for you, you should show some group of ID numbers. Some ID. Yeah. Docker server. And you need to restart your Docker. So let's move on to the next command. Please pay attention. So now we want to create the database. So this one we are not creating, we are not building our own image because there's already, we're using Postgres. There's already a Postgres image available on Docker Hub. Huh? Yeah, I've created the network. Okay. So the first thing you do is to copy this Docker network create. So Docker network create, then the name of your network. So this case is tax mgt-network. So copy and paste it into your terminal. So for me, I've created it before. So it's showing network already exists. But for you to show a group of numbers, alphanumeric characters, the name you want to give to your network, any name you want, but you can just use, because you'll be using that network name in the Docker run command. So if you use a different name, you have to ensure that in the Docker run command you use that name. I can okay, let me show you an example. For example, in the to create the database container, you can see I'm using network. Sorry. And just use the name in the practical, in the text of practical. If you use a different name in this place, Look at this place that I specify hyphen network. You have to use that network name that you used. Yeah. You can use the name you want, but if you're using a name you want, this place that you specify hyphen network, you have to use that name. Yeah. So you can use any name you want, but when you are creating the Docker containers, you have to specify that name. You have to remember that name. Okay. I've been made aware that someone has a question from online.
Yes, good morning. Very interesting presentation and session. Yesterday, I started with you, but I missed out on the installation. So the truth is, I want you to just give me a cue
Please
so I'll
come
be able
again.
to install. Hello, installing the Docker so that I can practice. All the commands you've explained, I understood. But now that you started the practice, I'm not able to follow. Please, can you give us a cue? Because I think most people online also are missing out on this, but I don't think anybody has indicated.
Sorry, I
Thank
didn't hear
you.
you clearly. Please come.
Hello. Okay, so sorry, can you hear me now? Good morning.
Yes, I can hear you now.
Okay, so sorry. So I said it's been very interesting. The principles and the commands, everything I got, but the installation aspect, I think I missed it out because I had a meeting yesterday, probably when you were explaining. I'm just assuming, but I've asked those online. Nobody seems to actually know. So if you can give us a cue on just installing this, so we can follow this hands-on practice, it will go a long way. Thanks.
Okay. If you want to install Docker, in the slides I gave you, there's a slide describing the link. Let me just quickly go back there. But that's in a way pulling us back seriously, but everyone is important. Okay. So if you go to this slide, you go to the Windows. If you are using Windows, you go to this link. Can you see the slides? Can you see the slides?
Yes, yes, yes.
Okay. So you can see this is for installing Docker. So we have Windows Docker installation, Mac Docker installation, and Linux Docker installation. So just click on the link that pertains to your operating system.
Okay.
Yeah. So read the software, the system requirements, and ensure your system can carry it. If it cannot carry it, just look down to the other links. So there's the Docker toolbox.
Okay.
So after the first three major bullet points, there's the other one for Mac and Windows users. If your machine doesn't meet the system requirements, please install Docker Toolbox. So you use the links either for Mac or for Windows. And if your system cannot carry Docker Toolbox, then you use the playground. But for the playground, you can't follow the practical we are doing right now.
Okay, I'll try out
So
what you just
I
said.
hope your system can carry the Docker desktop.
Okay. I'm using Windows, so I'll try out what you've just said for Windows. Thank you.
But we might not be able to wait for you because we did this
No,
in
no,
the
no.
first.
Go ahead. Go ahead. I just wanted to give you that you give a cue and then the others can go. Thank you. Thanks.
Yes. Okay. And the slides is actually on the WhatsApp platform. So you can go to the slide and also get the link from the
Yeah, I
slides.
just got it now. Thank you.
Yeah, you can also post your questions there. When I'm done with the class, I can address the questions.
All right, thanks. Sorry to draw you
Okay.
back.
Okay. So we have to move fast now. So we've created a network. The next thing is to create the database container. So to create a container, we use the docker run command. So the first thing we are doing here is specifying a name. This can be any name you want, but if you choose any name, you have to make sure you change it in some specific places. So just follow along with the name I use here. So we are specifying some environment variable here. This is needed by the Docker image so that I can create your Postgres user for you. Okay. Yeah, everything. Yes, we've executed network command. So I have a question here. Gangan. Okay, no time. Let me just explain it. So here we are creating a volume mount. I asked this question yesterday, but nobody got it. We are creating a volume mount, and this is a named volume. This is not a bind mount. This is a named volume. We are giving it a name. We are giving it a name, and we are specifying the path. So look at what I highlighted here. So we are creating a volume so that the database can back up its data. So we are giving it a name mount, and this is the part in the container we want to back up. So this is the part that Postgres database stores data. So we are backing up only that part in the database, in the container, I mean. So here we are saying when the container is removed, is deleted or stopped, remove it completely. This -d means run it in the background. If you don't run it in the background to print out log information and hold the terminal, then here we are using the network. So we want it to be in the network. So every other containers in this network will be able to talk to the database. So we are using the name of the network. If you used a different name, you have to specify the name that you used here. But running the background. So we are specifying more environment variables that the container needs to run: Postgres user and Postgres database, then the name of the image. So I can see that this command is very long. We will be using Docker Compose, which is a much more elegant way of running containers, several containers at once. So if you want to see Docker Compose, we have to run this very fast. Everything, all the commands is specified in a file. So you just run the file and to create all your containers for you. But now we have to do it like this. So you can run the line now. And to pull it from the, it will show pulling from, yeah. Okay, so please, were you able to run the command? That long line, just run it. So it will pull the image if you don't have the image. That's the way Docker runs. If it doesn't have the image, it will pull it. Yes, it's downloading. It will show a list of alphanumeric characters after it's done. So let's check if it's actually running, because we just ran it, but we don't know if it is running. So to run it, what command do you use to list all running containers? No, that's not complete. Docker PS, yeah. So type Docker PS. and let it finish. For those that it has finished, I think for some people it has finished. So type docker ps list your running containers. But what I want us to look at is the status. Is it running? That's, yeah, up about. So if it's running, you will see up. If there are errors, it will show exited. So you should be up. So it means it's running. So let's move to the next one because we don't have much time. So the next thing we want to do is to build the backend image. So go to the backend folder and let's look at the image, the Docker file, I mean. Okay, I think we have seen this Docker file a lot. I don't need to explain it again. Yeah, the backend folder. So this is the Docker file that we want to build an image of. So we want to build an image of this Docker file. The file, you go to the backend folder, then you see a Docker file. Not the Docker file.old, just the Docker file. So I just want you to see the Docker file. Go through it. Yeah. So now we want to build the image. So now we want to build the image. So to build the image, this is the command right here. Docker build -t. Then the name we want to give to the, bless you, the name we want to give to the image, then dots, which specify the context. So since we are specifying the context as the current working directory, we have to cd into the backend folder. So right now we want to build the image for that Docker file. So to build the image, you type docker build -t, then the name of the image, and dot. Dot specify the current working directory. So if we are using dot as the current working directory, we have to cd, change the directory into the backend folder. So we want to build the image. So to build the image, we use docker build -t, then the name of the image, then dot, which is the context. No, I talked about context before. So since we are using dots, which represent the current working directory, we have to cd, change directory into the backend folder. Or if you want to be advanced, you can just put /backend there. Anyone. So let's quickly do it so that we can see the application running. So for me, I'm changing directory into the backend folder. Yep. Yep. Slash backend. Yeah. Yeah. No, it will run on any terminal. And you have to change directory to that. Yeah. Okay, I think I know what you're talking about. Yeah, yeah. You are not in the container directory. Yeah. So you need to be in the container. That's the directory where the directory is private. But you can, what's the full path for someone? You can always get path. I did change it. I didn't. No, I gave you on version of forward. Normally you show the path. And that means you have to do it manually if you can get the path. So you have to see the path, change directory to this path. You get. It's simple now. There is nothing complex. What is your root directory? I'm coming. I'm coming, sir. Okay, you've done it. Sorry, for those using that are not using VS Code, you have to change your directory in your terminal to the path of the folder. So I think some of you experience error. So you have to change your directory to the path.
Hello. Yeah, we'll be going for our tea break now. So to come back by 11. But let me bring this to our attention. One of our facilitator is going to be online today, and that is Benoit, that took us last year from France. But this time around, he's currently based in Canada. So, and that's why we have his class for 3 to 6. Please, I create our indulgence to just sacrifice the extra 1 hour. It's just basically because of the time difference. Currently, he's sleeping. Our own, his own 9 a.m. is our own 3 p.m. So, and because he needs more time, so he's going to take us for 3 hours today, which is going to be 3 to 6. So he's going to be online. And he's going to do that today, tomorrow, and Monday. He has 3 days with us. So thank you. So just to let us know, I think you would have seen that on the timetable. It's because he is based in Canada and because of the time difference. Thank you. So I think we can go for our tea break and then to come back by 11. Thank you.